What has 3 Atlas done to Mars? Right now, somewhere between the Sun and Jupiter, an object roughly 5 kilometers across is coasting through our solar system on a trajectory that should not exist. It arrived from interstellar space on July 1st, 2025, designated 3I/Atlas, the third confirmed visitor from beyond our Sun's gravitational domain. And 3 weeks ago, on October 3rd, it executed what can only be described as a precision flyby of Mars, passing within 29 million kilometers of the red planet with a minimum orbit intersection distance of just 2.7 million kilometers. To put that in perspective, that's like threading a needle from across an ocean. Here's what keeps me awake at night. 7 spacecraft positioned around Mars were tasked with imaging this encounter. NASA's Mars Reconnaissance Orbiter, with its high-rise camera capable of 30 km per pixel resolution at that range. ESA's Mars Express, carrying the HRSC stereo camera and Omega spectrometer, the ExoMars Trace Gas Orbiter with its CASIS imaging system and Nomad spectrometer, MAVEN, the UAE's Hope Orbiter, China's Tianwen-1. Even NASA's Perseverance rover on the Martian surface attempted observations with its Mastcam-Z camera. The observation window ran from October 1st through October 7th. Then something peculiar happened. Silence. Let me be clear about what we're discussing here. This is not speculation about little green men or conspiracy theories about government cover-ups. This is about data, or more precisely, about the absence of data that should exist. When the European Space Agency finally released imagery from the ExoMars Trace Gas Orbiter on October 8th, it showed exactly what you'd expect from an instrument designed to photograph Mars from orbit, trying to capture something 18.6 million miles away. A fuzzy white dot, background stars streaked because the camera was tracking the comet's motion. The CASIS instrument was pushed to its absolute limits, imaging a target 10,000 to 100,000 times fainter than its usual subjects. Nick Thomas, the principal investigator for CASIS, stated plainly that this was a very challenging observation. Fair enough. But here's where the analogy breaks down. Imagine you're expecting a letter written in a language you barely understand. When it arrives, you can see the envelope, you can confirm something is inside, but you cannot read the message. That's the ExoMars image. Confirmation of presence, zero information about content. Now consider what NASA's high-rise camera aboard the Mars Reconnaissance Orbiter should have captured. High-rise is not CASIS. It's specifically designed for high-resolution imaging at distance. At 29 million kilometers, it should have achieved 30 km per pixel resolution of 3I/Atlas. That's detailed enough to separate the nucleus from the surrounding coma, to distinguish between the solid icy core and the cloud of dust and gas being stripped away by solar radiation. The HiRISE team has successfully imaged objects across the solar system when conditions allowed. This was one of those conditions. As of October 28th, no HiRISE images of 3I/Atlas from the October 3rd flyby have been publicly released. Mars Express, with its multiple spectrometers, Omega and SPECOM, was positioned to analyze the chemical composition of the comet's outgassing. The Nomad spectrometer on ExoMars TGO was tasked with the same objective. These are not low-priority instruments. Nomad was specifically designed to detect trace gases in the Martian atmosphere by measuring their spectral signatures. A comet actively sublimating volatiles at 29 million kilometers presents a target orders of magnitude brighter than atmospheric trace gases. The spectroscopic data from these instruments has not been released. The NASA assets tell the same story. No confirmed images from Perseverance. despite an astrophotographer named Simeon Schmaus claiming to have stacked publicly available Mastcam Z frames and identified a faint smudge at the predicted position of 3I/Atlas in the Martian sky on October 4th. NASA has not confirmed or denied this identification. The agency's public outreach office closed due to a government shutdown that coincidentally aligned with the observation window. That's the timeline. October 1st, observation window opens. October 3rd, closest approach at 4 UTC. October 8th, ESA releases one set of images showing a white dot. Everything else, crickets. We're now 25 days past the event. The Hubble Space Telescope imaged 3I/Atlas on July 21st from 570 million kilometers away, obtaining the highest resolution imagery available at that time, revealing a teardrop-shaped coma with clear asymmetry. That data was released on August 7th, 17 days after observation. The James Webb Space Telescope observed 3I/Atlas on August 6th using its NIRSPEC instrument, detecting carbon dioxide, water, carbon monoxide, carbonyl sulfide, and water ice in the coma. That data informed multiple scientific papers published in August and September. We are past the normal release cadence. Let that sink in. Before we spiral into unfounded speculation, let's establish what 3I/Atlas is confirmed to be. It's a comet, active, sublimating volatiles as it approaches perihelion, which will occur on October 30th at 1.4 astronomical units from the Sun, just inside the orbit of Mars. Hubble observations, as of August 20th, constrained the nucleus diameter to between 440 meters and 5.6 kilometers. Current best estimates suggest approximately 5 kilometers, with a mass exceeding 33 billion tons. That makes it substantially more massive than either of the previous interstellar visitors, 1I/Oumuamua, which was asteroid-like and possibly as small as 100 meters, or 2I/Borisov, which was a more typical comet around 1 kilometer in diameter. 3I/Atlas is big. The Atlas survey in Rio Hurtado, Chile, first detected it on July 1st, though pre-recovery observations from the Zwicky Transient Facility and multiple Atlas telescopes extend back to May 21st. It was already active at 6.4 astronomical units from the Sun in May, far beyond the distance where water ice typically begins to sublimate, suggesting its activity is driven by more volatile compounds like carbon dioxide or carbon monoxide. JWST spectroscopy confirmed this, showing the highest carbon dioxide to water ratio ever measured in a comet, interstellar, or otherwise. The trajectory is where things get interesting. 3I/Atlas entered the inner solar system on a hyperbolic orbit inclined just 4.89 degrees relative to the ecliptic plane. The plane defined by Earth's orbit around the Sunday. Mars orbits at 1.9 degrees inclination, Jupiter at 1.3 degrees. The Milky Way's galactic plane is inclined approximately 60 degrees relative to our ecliptic. Objects arriving from interstellar space should, statistically, arrive from all directions with roughly equal probability. 1I/Oumuamua arrived at 123 degrees inclination. 2I/Borisov at 44 degrees. The probability of an interstellar object naturally arriving within 5 degrees of the ecliptic plane is roughly 0.2%, 1 in 500. That's the first anomaly. But wait, there's more. For 3I/Atlas to pass within its minimum orbit intersection distance of 2.7 million kilometers from Mars's complete orbital path, and then to actually be at that closest point when Mars itself was also at that point in its orbit, requires a second coincidence. Mars takes 687 Earth days to complete one orbit. The window during which Mars would be positioned for a close encounter with an object on 3 ATLAS's trajectory is measured in days, possibly hours. The combined probability of both the orbital plane alignment and the timing coincidence has been calculated at less than 1 in a million. Here is where a responsible science communicator must tread carefully. Low probability events happen. The universe is vast. Given enough interstellar objects traversing enough star systems over enough time, eventually one will thread this particular needle. We must not leap from statistically unlikely to therefore artificial without extraordinary evidence. And yet, we must also not ignore the data we do have. So let's examine the improbability stack piece by piece. First, the inclination. As mentioned, 4.89 degrees. The Milky Way disk's misalignment with our ecliptic is 10 times that angle. The solid angle probability scales with the square of the angular separation. If 3 I/Atlas were launched by an extraterrestrial civilization that discovered our solar system via transit observations, watching our planets cross the face of the sun from some distant vantage point, they would see those transits only from within a conical disk aligned with our ecliptic. The opening angle of that disk depends on the sensitivity of their instruments. If they wanted to send a probe that would pass near multiple planets, aligning with the ecliptic makes sense. But that's speculation. Natural origin remains the null hypothesis. Second, the timing. October 3rd for Mars, March 16th, 2026 for Jupiter, passing within 54 million kilometers. That's 2 planetary encounters from a single interstellar trajectory. Again, the combined timing probability given the circumferences of both orbits is estimated at 0.02%. Multiply that by the inclination probability, you get 1 in a million. But here's the thing about probability. It only tells you how surprised you should be after the fact. It doesn't tell you whether something is designed or coincidental. If you flip a coin 1 million times and get a specific sequence of heads and tails, that exact sequence has a 1 in 2 to the 1 millionth power chance of occurring an incomprehensibly small number, yet it just happened. Every specific sequence is equally improbable. This is called the lottery fallacy. We only notice the unlikely events that seem meaningful. A comet passing near Mars doesn't seem meaningful until we start asking whether it might be more than a comet. Then suddenly the low probability feels significant. This is pattern seeking, and we must acknowledge it as such. And yet, 3 more anomalies demand attention. Third, composition. JWST data show that carbon dioxide to water ratio, the highest ever recorded. Keck Observatory observations on August 24th revealed prominent nickel emission in the coma, but no iron. This nickel without iron signature is known in exactly one context outside of 3 I/Atlas, industrial production of nickel through the carbonyl chemical pathway, which creates and decomposes nickel tetracarbonyl. Now, before we run off claiming this proves artificial origin, understand that we don't know all possible natural astrophysical processes. Nickel and iron are common in comets. Perhaps some unknown sublimation chemistry preferentially releases nickel under specific temperature and radiation conditions. Perhaps the parent body from which 3 I/Atlas originated had an unusual formation history. The paper reporting this finding by W.B. Hugendam and colleagues noted the anomaly but proposed no artificial origin. They simply stated it's unusual and warrants further study. The nickel production rate relative to cyanide is orders of magnitude above the solar system comet median. Orders of magnitude. That's not a small deviation. That's a different category of object. Fourth, morphology. Both Hubble and Keck images show an antitail, a plume, extending toward the sun, not just away from it. This is bizarre. Cometary tails form because solar wind and radiation pressure push dust and gas away from the sunday. An antitail suggests active jetting from the sun-facing side, material being expelled with enough velocity to overcome solar radiation pressure, at least temporarily. 2I/Borisov showed typical cometary behavior, tail streaming away from the sunday. 3I/Atlas shows asymmetric emission in both solar and anti-solar directions. In cyanide emission, yes. In nickel emission, yes. But in white light, the expected dust tail that should scatter sunlight is weak or absent. This is not how comets typically behave. The white light image shows a coma, but no prominent tail structure. The gas emissions show a tail and an anti-tail. That's contradictory unless the dust and gas are decoupled in some unusual way, or unless the dust grain sizes or composition differ from typical comets. Again, we don't have enough data to conclude artificial origin, but we have enough data to say this object is not behaving like 2I/Borisov or any well-studied solar system comet. Fifth, photometric behavior. Some observers have reported variations in brightness that suggest either internal processes, structural evolution, or rotational asymmetry. If 3I/Atlas is tumbling or rotating, and if its surface reflectivity or outgassing is non-uniform, we'd expect brightness fluctuations. This is common in comets, but the specific pattern observed, if confirmed, might indicate something more interesting. I say if confirmed, because as of October 28th, no peer-reviewed photometric analysis of 3I/Atlas during the Mars encounter has been published. The pre-encounter data exists. The Mars flyby data should exist. Where is it? Sixth, trajectory precision. I mentioned the minimum orbit intersection distance already, but let's go deeper. An object arriving from interstellar space travels at high velocity relative to the sunday. When 3I/ADLAS was discovered, it was moving at 137,000 miles per hour, roughly 61 kilometers per second. As it approaches the sun, gravitational acceleration increases that velocity. To alter its trajectory enough to reduce the Mars' closest approach from 29 million kilometers to zero to actually impact Mars would require a delta V, a change in velocity, of 10 to 15 kilometers per second during September. That's substantial. Natural outgassing from a comet can produce thrust, the so-called rocket effect, but typically on the order of meters per second, not kilometers per second. However, if 3I/Atlas is very active, if it's shedding mass asymmetrically, if it fragments, those scenarios can produce larger trajectory changes. The point is, we're talking about an object whose path brings it close to Mars and later close to Jupiter, two encounters that require very specific entry conditions into our solar system. The trajectory had to be just right billions of kilometers ago before it even entered the heliosphere. Natural? Possible? Designed? Also possible. We lack sufficient evidence to decide. Seventh, and this is the speculative cherry on top, angular alignment. In August 1977, the Big Ear radio telescope at Ohio State University detected a strong narrowband radio signal at 1,420 megahertz, the hydrogen line, a frequency considered likely for interstellar communication because it's a universal marker in the spectrum of any technological civilization that studies radio astronomy. The signal lasted 72 seconds, was never detected again, and has since been called the WOW signal, after astronomer Jerry Eamon's annotation on the printout. The direction from which the WOW signal appeared to originate, in the constellation Sagittarius, is within a few degrees of the incoming trajectory, direction of 3I/Atlas, accounting for proper motion and uncertainty over nearly 50 years. Coincidence? Almost certainly. The positional uncertainty on the WOW signal is large. The sky is big. Drawing a connection between an unexplained radio signal from 48 years ago and an interstellar comet today requires a level of optimism that borders on wishful thinking, but it's on the list. 7 anomalies: inclination, timing, composition, morphology, photometry, trajectory precision, angular correlation with WOW. Individually, most have plausible natural explanations. Collectively, they form a pattern that refuses to resolve cleanly. Here's the terrifying part. If 3I/Atlas is not just a comet, if it is something else, a probe, an artifact, an engineering project launched by an intelligence we cannot begin to comprehend, then its close approach to Mars on October 3rd was not a random flyby. It was an observation, or a test, or a delivery. And the silence from the Mars orbiter data pipeline is not bureaucratic delay. It's coordination. I don't believe that. Let me state clearly, I do not believe that 3I/Atlas is an alien spacecraft, and I do not believe NASA or ESA are suppressing data. But I understand why some people do believe those things. The absence of data creates a vacuum, and humans fill vacuums with narrative. The conspiracy-minded will see cover-up. The skeptical will see normal scientific review processes. Both are reading meaning into the same silence. What I do believe is that we need the data, all of it. The high-rise images, the nomad spectra, the SPICHAM and Omega measurements, the confirmed or denied identification of 3I/Atlas in Perseverance's images. We need photometric light curves from the October 1st through 7th observation window. We need trajectory refinement from the close approach, because if there was any non-gravitational acceleration, any course correction, any indication that 3I/Atlas changed velocity or direction during the Mars encounter, that would be significant. We also need the post-perihelion data. 3I/Atlas reached its closest point to the Sun on October 30th, just 2 days ago. At perihelion, solar flux is at maximum. Sublimation is at maximum. If this object is going to do anything dramatic, break apart, deploy something, suddenly alter course, perihelion is when it happens. Unfortunately, 3I/Atlas is currently behind the Sun as seen from Earth. Solar conjunction. We cannot observe it. Ground-based telescopes cannot track it. Space-based telescopes like Hubble and JWST risk damage pointing too close to the sunday. There is a blackout window that extends from late October through mid-November. Around November 11th, 3I/Atlas should emerge from behind the Sun, visible in the morning sky for telescope users. If it reappears as expected, if it continues on its predicted trajectory outbound toward Jupiter, if it shows normal cometary activity consistent with a cooling object moving away from perihelion, then fine. Mystery persists, but danger, if there ever was danger, recedes. If it does not reappear, or if it reappears in the wrong place, or if its activity changes in unexpected ways, then we have a new conversation. The European Space Agency's JUICE spacecraft, currently en route to Jupiter, will attempt observations of 3 ATAS I/Atlas in November from its unique vantage point closer to the Sunday. JUICE will see the comet in a more active state than the Mars orbiters did shortly after perihelion, when outgassing is still intense. However, JUICE is currently using its high-gain antenna as a heat shield and is transmitting data at reduced rates via its medium-gain antenna. We should not expect to receive JUICE data until February 2026. That's 3 months of waiting. Meanwhile, 3I/Atlas will continue toward Jupiter, reaching its closest approach on March 16, 2026, at 54 million kilometers. NASA's Juno spacecraft orbits Jupiter but has limited fuel and thruster issues, making a redirection to observe the comet unlikely. However, natural line-of-sight observations might still be possible. ESA's JUICE will have a better view. Other assets potentially in position include the Psyche spacecraft, which will pass approximately 0.4 astronomical units, 60 million kilometers, from 3 ATAS/Atlas. All of these are post-perihelion observations. The critical moment, the moment when we learn whether this object is natural or something else, is now, late October and early November. Perihelion and reappearance. If NASA or ESA are holding back images from the Mars flyby, they need to release them before the comet's behavior at perihelion either confirms natural origin or raises new questions. If they wait until February to release JUICE data, and 3I/Atlas has by then altered course, fragmented unexpectedly, or deployed sub-objects, the credibility damage will be catastrophic. Not because of what the object is, but because of the perception that information was controlled. Transparency is the only defense against conspiracy theories. So let me lay out 3 interpretive scenarios. 3 ways to make sense of the data we have and the data we don't have. First, the benign scenario. 3I/Atlas is a natural interstellar comet older than our solar system by 3 billion years, with unusual composition due to formation in a different protoplanetary environment, possibly around a star with different metallicity or radiation history. Its trajectory is coincidentally well aligned with our ecliptic, a 1 in a million event, but 1 in a million events happen given the billions of comets that must exist in the galaxy. Its high carbon dioxide to water ratio reflects formation at low temperatures far from its parent star, consistent with an object spending billions of years in interstellar space. The nickel without iron signature is an unknown but natural astrophysical process we haven't encountered before because we've never studied an interstellar comet this closely with instruments this sensitive. The anti-tail is explained by asymmetric jetting from an irregularly shaped rotating nucleus. The missing Mars orbiter data is delayed by normal peer review and analysis timelines. Scientists want to be sure before they publish. The government shut down complicated communications. We'll have the data soon. Everything is fine. This scenario is consistent with all observations and requires no extraordinary assumptions. It is the null hypothesis. We should default to it until evidence forces us elsewhere. Second, the warning scenario. 3I/Atlas is a natural comet, but its trajectory was influenced by a gravitational encounter in interstellar space, possibly with a rogue planet or brown dwarf, that coincidentally deflected it toward our solar system and onto this precise trajectory. Alternatively, it is a natural comet, but one that was deliberately deflected by an extraterrestrial intelligence as a passive signal, a gravitational calling card. Imagine a civilization capable of detecting exoplanets and wanting to announce their presence. Instead of broadcasting radio signals into the void, they nudge comets onto trajectories that pass near inhabited systems. The comet itself is natural. The trajectory is engineered. No need for propulsion or exotic materials, just a carefully calculated gravitational assist somewhere in the dark between stars decades or centuries ago, timed so the comet arrives now. This would explain the trajectory precision without requiring the comet itself to be artificial. It would explain the lack of obvious technological signatures, no radio emissions, no thermal anomalies, no structural features inconsistent with a comet because it is a comet. The message is the trajectory. The medium is the motion. This scenario is more speculative, requires intent and capability from an unseen actor, but remains consistent with observations. We could not distinguish a nudged comet from a natural one unless we had before and after trajectory data from deep space, which we don't. Third, the diagnostic scenario. 3I/Atlas is a probe, not a crewed vessel, not an invasion fleet, but an autonomous reconnaissance platform doing exactly what the Mars orbiters were doing on October 3rd. Observing, it passed Mars to measure the planet's atmosphere, magnetic field, radiation environment. It will pass Jupiter for the same reason. Its entry trajectory was designed to maximize useful encounters while minimizing fuel expenditure, threading through our solar system on a path that leverages gravity assists from the Sun and possibly the planets. Its composition is engineered. The high carbon dioxide content is not coincidental, but functional, providing propellant for minor course corrections via controlled outgassing. The nickel emission is a byproduct of onboard processing, energy generation, or instrumentation. The anti-tail is directed thrust, not random jetting. The mass, 33 billion tons, is not excessive for a multi-generational interstellar mission. Starship, humanity's largest rocket, masses 5,000 tons. A probe, 33 billion tons heavy, is 6 million times more massive, but also potentially capable of carrying instruments, shielding, redundancy, and fuel sufficient for a journey measured in millennia. It need not be fast, it need only be patient. This scenario is the most extraordinary and requires the most extraordinary evidence which we currently lack, but it is not impossible. How do we choose between these scenarios? Evidence, observation, the scientific method. Here is what we need to watch for in the coming weeks and months. First, does 3I/Atlas reappear on schedule around November 11th? If yes, does its brightness, morphology, and spectrum match predictions for a comet cooling after perihelion? If no, or if it reappears with unexpected characteristics, flag raised. Second, does post-perihelion trajectory refinement show any non-gravitational acceleration inconsistent with normal cometary outgassing? Comets experience non-gravitational forces from asymmetric sublimation all the time. This is measurable and well understood. If 3I/Atlas shows acceleration magnitudes or directions that cannot be explained by plausible outgassing models, flag raised. Third, do JUICE observations in November show any structural features, any deployed subobjects, any emissions at non-thermal wavelengths? If yes, flag raised. Fourth, does the object fragment? Comets fragment. It's common, especially near perihelion. If 3I/Atlas breaks apart into multiple pieces that continue on divergent trajectories, that's consistent with natural fragmentation. If it breaks apart into multiple pieces that execute coordinated maneuvers, flag raised. Fifth, do the missing Mars orbiter images and spectra eventually appear? If yes, do they show anything anomalous? If no, why not? The data timeline is our countdown clock. November 11th, potential reappearance in morning sky, Earth-based telescopes can resume tracking. Mid-November through December, ground-based observatories worldwide will attempt spectroscopy, photometry, imaging. December, JWST scheduled to observe 3I/Atlas again post-perihelion, comparing composition and activity to pre-perihelion data. Any changes are significant. February 2026, JUICE data expected to arrive March 16, 2026, Jupiter closest approach. That's the outer boundary of our observation window. After 3I/Atlas passes Jupiter, it will recede into the outer solar system, accelerating on its hyperbolic trajectory, heading back into interstellar space. If we haven't resolved the questions by then, we may never resolve them. The object will fade, instruments will lose tracking, and it will become one more mystery in a universe full of mysteries. Unless, of course, it does something undeniable. If it alters course toward Earth after the Jupiter flyby, we'll know. If it deploys a communications array and starts broadcasting, we'll know. If it impacts Mars or Jupiter or releases a swarm of smaller probes, we'll know. Those scenarios are, I must emphasize, vanishingly unlikely, but they are scenarios. They are on the table. Not because we have evidence for them, but because we have incomplete evidence against them. That's the nature of the situation. We are in a state of uncertainty, bounded by data on one side and imagination on the other. This is a scientific process at its most thrilling and most frustrating. We observe, we hypothesize, we test, we revise. The null hypothesis, natural comet, remains the leading explanation. But science is not about defending the null hypothesis reflexively. It's about following the evidence wherever it leads. If the evidence eventually points toward artificial origin, we must be willing to accept that conclusion, no matter how uncomfortable. If the evidence continues to support natural origin, we must also accept that, no matter how disappointing. Right now, we are in the gap between observation and conclusion. The Mars flyby happened. The data exists or should exist. The perihelion passage happened 2 days ago. The post-perihelion behavior will unfold over the coming weeks. And we, collectively as a species, are watching amateurs with backyard telescopes, graduate students crunching orbital mechanics, mission scientists at NASA and ESA poring over every pixel of every image, radio astronomers sweeping the sky for any anomalous signal. We are all waiting for the same thing: clarity. If you want to stay on the timeline as this unfolds, you know what to do. Subscribe, not for the algorithm, not for the content, but because 3I/Atlas is on a schedule, and if something happens, if the reappearance is anomalous, if JUICE sees something unexpected, if the trajectory changes, you will want to know immediately. The next few weeks are critical. November 11th is circled on the calendar. February 2026 is circled. March 16, 2026 is circled. These are not arbitrary dates. These are observation windows where the object is positioned for maximum data return. Miss them, and we miss the answers. Drop a comment and tell me where you land. Is this just sophisticated pattern seeking, humans drawing connections where none exist, seeing design in randomness because our brains are wired that way? Or is the improbability stack too tall to ignore? Are we watching a natural comet with unusual properties, a statistical outlier that teaches us something new about interstellar space? Or are we watching first contact, not with beings, but with evidence of beings, a probe, a messenger, a diagnostic tool sent by something or someone with capabilities beyond our current understanding. Here is what I know. Space is vast. The galaxy contains hundreds of billions of stars, trillions of planets, an unimaginable number of comets. Life, if it exists elsewhere, might be common or rare, but intelligence capable of interstellar engineering is, by necessity, rare enough that we have not yet detected it definitively. The Drake equation, the Fermi paradox, the Great Silence, all of these point to the same conclusion. Either we are alone, which is terrifying, or we are not alone, which is equally terrifying. 3 I/Atlas does not resolve that question. It sharpens it. An interstellar object on an improbable trajectory with anomalous properties passing near Mars and Jupiter while we happen to have instruments positioned to observe it. Coincidence? Probably. Probably. But probability is not certainty. We will know more in 2 weeks. We will know more in 3 months. We will know more in 5 months. And if we are very lucky or very unlucky, depending on your perspective, we might learn that the universe is less empty than we thought. The question that haunts every astronomer who looks up at the night sky is simple. Are we alone? 3 I/Atlas has not answered that question. But it has reminded us, with its improbable inclination and its precise timing and its unusual chemistry and its passage past Mars and its upcoming reappearance, that the universe is under no obligation to conform to our expectations. Natural or artificial, comet or probe, coincidence or design, 3 I/Atlas is out there right now, coasting through the void, carrying answers we do not yet possess. In 2 weeks, it emerges from behind the sundae. We point our telescopes, we measure, we analyze, and maybe, just maybe, we learn something extraordinary. Or maybe we confirm what we already suspected, that space is cold, that comets are ice and rock, and that we remain, for now, alone. Either way, we watch, because that is what we do. We are a species that looks up. We are a species that asks questions. We are a species that builds instruments to pierce the dark and interrogate the light. And when an interstellar visitor arrives on an impossible trajectory, we do not look away. We lean in, we gather data, we debate interpretations, we wait for the next observation window, and we remind ourselves that the universe is vast and strange and full of objects we do not yet understand. 3 I/Atlas is one of those objects. Right now, behind the sun, invisible, unknowable. In 2 weeks, visible, measurable. And we will see what we will see.